Okay, we want to take a look at graphing a transformed cosine function. I have an example of one here, and what the big thing I want to emphasize is that we're going to look at the angle start at 0 and the angle end at 2 pi to get one complete cycle. Okay? One complete cycle of the cosine function. We already know that. Furthermore, we know that at 0, we know the cosine function starts at the top, and at 2 pi it ends at the top. Halfway in between it's at the bottom, and then halfway between there and there it's at the average value. So it looks something like that when your angle goes from 0 to 2 pi. What we need to do is, our angle now is not x, so there's not a direct relationship between x and the angle. Instead, we need to figure out what this tells us, what this angle stuff tells us about x, because that's what relates to our graph. X and y are on our graph. So I need to learn about that angle to learn about x so I can graph something. Furthermore, sorry, let me change my original function here. Let's do a +1 on the end, or how about a +3 on the end of this function. Everything outside of the angle, so our angle tells us about x, which is what we're going to figure out later. Everything outside of that part of it tells us about y. So this -2 and this +3 affect the y values of the graph. And so we'll see that as well. So what we're going to have is, we're going to have, if we look at the -2 here, our y values are going to be multiplied by -2. If you've done transformations in algebra, that's exactly what this is. So over here, if I take, remember this is typically like 0, this is 1, and this is -1. If I multiply all those y values by -2, this is what I get. I get a different picture where my graph starts at the bottom and ends at the bottom. In the middle, it's at the top, and in between those, again, it's at the average value. So this is what our complete cycle is going to look like. So the negative here flips our graph over. You can see that the graph here has been flipped this way, and the 2 means that the top now is 2 and the bottom is now -2. The average value is still 0. Okay, finally, this +3 here is going to, I bet you can guess, add 3 to the y values. So these y values over here, we're going to add 3 to those. So instead of -2, 0, and 2, we will have 1, 3, and 5. 3 will be the average value of our graph. So we've already got that established. Alright, so I know when I go to set my graph up, I'm going to have it like this, something like this. The middle is not going to be 0, it's going to be 3. So this really is not the x-axis. The top will be, let's say that's 5. And the bottom will be 1. So notice here, I used 3 tick marks for 2 for a unit of 2, because from 3 to 5 is 2 units, okay? So I made sure to be consistent on the bottom as well. So my graph has a nice symmetry to it. Alright, good. Now I just need to figure out this x business. Alright, that's what we're looking at now. So if I want my graph to, my angle to start at 0, I need to set my angle 3x plus pi over 2 equal to 0. This will be the start of my cycle. If I solve that for x, I'll subtract pi over 2 and then divide by 3. I'll get negative pi over 6. So my graph will start at negative pi over 6. It will end whenever my angle, 3x plus pi over 2, is 2 pi. So I'll set 3x plus pi over 2 equal to 2 pi. Again, I'll subtract pi over 2 from 4 pi over 2 to get 3 pi over 2, and then I'll divide by 3 to get 3 pi over 6, which does reduce, but I'm purposely leaving it in terms of pi over 6's, so that when I go to graph it, it's very simple. I will set my graph up so that it takes, let's say pi over 6 is 2 tick marks. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6. So I'm setting up my scale now in the horizontal direction. And I need to have negative pi over 6 as well. So I'll go backwards 2 tick marks, and that will be negative pi over 6. So now once I have a consistent scale, it's very clear that, of course, this would be 2 pi over 6, right? And I could continue this as much as I want. So from negative pi over 6 to 3 pi over 6 is one complete cycle. In my graph, one complete cycle of this graph looks like that. So I'll transfer this picture to my graph. So I'll start at the bottom at negative pi over 6, so that's 1 in this case. I'll also end at 1. In the middle, which is at pi over 6, I'll be up here at the top. And then in between those, I'll be at 0, my average value of 3. So one complete cycle of this graph looks like this. And there we go. Of course, this graph goes on forever, so I could continue it, of course. And I could be more precise, however precise I wanted to go. It goes forever to the right and forever to the left. So that's one complete cycle. Now, let's determine the period of this function. The period from negative pi over 6 to 3 pi over 6, all I have to do is count. I've got 1 pi over 6, 2, 3, 4 pi over 6's. So my period is 4 pi over 6, or same thing as 2 pi over 3. You could also see that at any point along the graph, wherever the pattern continues, or repeats, I'm sorry. This, of course, would be 4 pi over 6. If I start measuring my function here, then it goes through one complete cycle to this point. So you can see that that is also from 0 to 4 pi over 6 gives me a period of 4 pi over 6. Okay, let's get the amplitude of this function. The amplitude is how far I deviate from my average value. Well, from 3, I go up 2, and I go down 2. So my amplitude is 2. Okay, finally, my average value is 3. That's the value around which I oscillate. Probably would have made more sense to state the average value before I stated the amplitude, right? Just slipped my mind. I apologize for that. So that's how you graph a transformed function. The angle will tell you about your x values, because you want your angle to start and end at 2 pi for the cosine function. And then everything outside of the cosine function, outside of the trig function, like negative 2 and 3, will tell you what happens with your y values, which is what we looked at over here. And you have to know the basic behavior of your function on the interval 0 to 2 pi that you chose. And so we've got that as well. And that's how we graphed this cosine function.